Good morning, dear children. In the previous video, we have learned about electric charges and its properties, and also the scalar form of Coulomb's law. In today's video, we will learn more about the vectorial form of Coulomb's law. In some of the book, you will find this as also vector form of Coulomb's law. Now, in the previous video, we never talk about the direction of the force experienced by the two charges. In what direction the force is pointing, we never mention about it. So it is, moreover, we discuss only in the magnitude only, not in the direction of the force along which the force will be acting. Now, in today's class, we will try to learn along with the direction how it will be represented, how the Coulomb's force will be represented along, in what direction it will have to point. We will have to deal with it along with the direction, I mean. So let's take it two charges Q1 and Q2, which are separated by some distance, say small r, in between the two charges. Then the Coulomb's force experienced by Q1 due to Q2 is denoted by F12. The first letter represents the force that will experience by the charge, which charge Q1. The first letter will be the charge which will experience due to the second charge. That means the first letter will be the force experience due to the second letter. That means Q2. So then Coulomb's force experienced by Q1 due to Q2 will be represented by F12 is equal to K. K means your electrostatic force constant. Yesterday we have done that one in a previous class, I mean. And Q1 and Q2, the two charges, magnitude over two charges, divided by distance square. And now here it is representing the direction. Up till here, K, Q1, Q2 divided by R square, it is yesterday's. That means your scalar form of the Coulomb's law. That means this will only give the magnitude of this force, and this R21 cap will represent the direction. So this is a unit vector, and we know that in a unit vector it will represent only the direction because its magnitude is always 1. That is why we call it as a unit vector. Magnitude is 1, direction will be acting along the direction of the vector R21. R21 means it will be representing from the charge 2 to the charge Q1. That means from 2 to 1 along this direction. So R21 is in this direction, a unit vector along from the second charge Q2 to Q1. And I have also given here the description where R21 cap is a unit vector from Q2 to Q1. It is given here. Similarly, Coulomb's force experienced by the charge Q2 due to Q1 is F21 vector. That means the force will be experienced by the second charge due to the first charge. And the force that will be acting onto the second charge due to the first charge will be acting along in this direction, because this charge, we will treat this charge as mobile, and due to the experience of the force by this Q2, because of this Q1, the force will be acting along this. That means if this charge is treated as mobile, that means movable, then this charge Q2 would have been moving along this direction. So F21 vector will be equal to, similar to this, K times of Q1 Q2 divided by R square, and the direction will be in this direction. R12 means r12 means along this direction. So this direction and this direction are same, r12 cape. So this r12 cape is a unit vector along this direction from 1 to 2. That means it will be along from 1 to 2, means it will be acting along this force F21 vector. But we know that this r12 cap and r21 cap, these are all unit vector along a straight line, on a straight line, but they are opposite to each other. So what happens when in a vector is represented in which the two vectors are opposite, then we generally write it with 1 minus. So r12 cap is equal to minus r21 cap. So if we replace this r12 here, replacing here, then what happened? The magnitude will remain same, but 1 minus is coming up. So what happened? We can write it from these two relation, f12 vector and f21 vector. F12 vector is equal to minus of f21 vector. So from here, from this above equation, we can know that the force exerted by the two charges on each other are equal but opposite because of this minus. So when one force due to this charge is acted due to this charge, what happened? The force experienced by Q2 due to this Q1, the force will be acting along this direction. The force experienced by Q1 due to Q2 will be acting along this. But these two forces are equal in magnitude, but the direction will be opposite. So for representing the vectorial form of Coulomb's law, this either the F12 or F21 will give you the vectorial form of Coulomb's law, because this force gives what as the magnitude as well as a direction, the direction in which the force will be acting, that will be also given by this unit vector. So this form of representation, we call it this as vectorial form of Coulomb's law. Now let's try to learn about the Coulomb's law or Coulomb's force in terms of the position vector of the two charges. So as I have already written the notes here so as to make easier for you as well as me. Yesterday while I'm teaching and while I'm writing there, it takes long time, and moreover it takes also takes long time, and at the same time while I'm writing very fast, my handwriting is also not so good. So let me do like this just to help you more. So let's start this Coulomb's force in terms of their position vectors. Now let's consider two charges Q1 and Q2 separated by this distance AB and having position vectors R1 vector for Q1 and for this Q2 let R2 vector represent its position vector, and these two charges are placed in vacuum. So it is written here in the description. Then Coulomb's force acting on to this charge Q2 due to the charge Q1 will be represented by F21 vector. And we know that from that previous vectorial form of Coulomb's law, this will be K, that means your electrostatic force constant, as it is placed, the two charges are placed in vacuum. What happens? Your K will be equal to 1 by 4 pi epsilon naught. The product of the two charges Q1, Q2, I mean the magnitude of the two charges, divided by distance square, AB square. This AB, while I am writing here AB vector, magnitude of AB vector, magnitude of AB vector, it will be represented by the modulus like this, and this will be also equal to the magnitude of the vector BA. When the vector is pointing from A to B, we call it as AB vector. When the vector is pointing from B to A, we call it as BA vector. But if you take it modulus of both, that means it will represent simply the length in between A and B. Whether it may be from A to B or B to A is immaterial. It is only the length. AB it will represent. So these will represent the distance AB. So distance square. And we know that the force F21 is what? Force experienced by Q2 due to this. So force will be acting along this. So this direction F21 is in the direction of R12 cap. So I have to represent it with R12 cap like this. Will be equal to 1 by 4 pi epsilon naught Q1 Q2. You keep it as like this. And for this AB vector, you write it as R12. Here I am giving here R12 vector. 1 2 vector means starting from 1 to 2. That's why I am just writing as the notation R12 vector. This will be equal to R12 vector. That means the modulus of R12 vector into R12 cap. That means if you want to write a vector quantity, then it should have its magnitude as well as direction. So that is expressing your AB vector as R12 vector will be equal to magnitude of these AB. That means it will be R12 vector modulus of R12 vector and R12 cap. That means it is along this direction AB vector. So you represent it with that R12 cap unit vector. If you want to express this R12 cap, then R12 cap will be equal to R12 vector divided by the magnitude of this vector. So if you divide it here, then you will get this expression. So what happened? Instead of R12 cap, you replace it by R12 vector divided by modulus of R12 vector. Now this can be written again as 1 by 4 pi epsilon naught, as you keep it as it is. Q1, Q2, you keep it as it is. But this modulus of R12 vector square. So R12 vector, this will be represented by what? R12 vector. If you take it this as a triangle, by remembering that the triangle law of vector addition in class 11, if you take it this as a resultant, then your OB will be equal to OA plus AB. OA plus AB taken in order, this will be equal to the third side taken in the opposite order, OB. So OB vector will be equal to OA vector plus AB vector. So if you try to represent these in terms of their position vector, then OB vector means it will be R2 vector will be equal to what? R1 plus R1 vector, R1 vector plus R12 vector. That is what I'm writing here. So if you want to represent this R12 vector, then you transfer this to the left side, then it will be R2 vector minus R1 vector will be equal to R12 vector. So these R12 vector, which is equal to R2 vector minus R1, you replace it here. And don't forget to put modulus here. This modulus should remain same. That square should also remain same. And same thing here, you have to represent this R12 vector here also with the modulus. And this R12 vector, you represent it here like this. As there was no modulus here, no modulus here, because this is a vector. But these are not vectors. Rather, these are the magnitudes only because of that modulus. So what happened? This F21 vector will be equal to what? 1 by 4 pi epsilon naught Q1 Q2. You keep it like this. These and these are same. So the modulus R2 vector minus R1 vector modulus same. So this is 2. So you have another one here, so it will be cube. When you multiply it, it will be cube. So what happened? The numerator r2 vector minus r1 vector remains. So this will be the Coulomb's force experienced by the second charge due to the first charge in terms of their position vector. The mnemonics here, it is very simple to remember. Now here the subscripts, the symbolic notations, or rather the subscripts written here is from the force experienced by the second charge 2 due to the first charge 2 1 is there. So this 1 by 4 pi epsilon naught q1 q2 will remain same, but here if it is 2 here, here also 2 2 first is there. When 1 is here, 1 1 are there. So 2 1 2 1 2 1 like that. So similarly, if you are going to write a Coulomb's force acting on the first charge q1 due to the second charge q2, then it will be expressed by taking the analogy from here. This f12 vector, this will be equal to 1 by 4 pi epsilon naught q1 q2, which are the same. So q1 q2 will be given writing there, and here within the modulus r1, as it is starting from 1 to 2, so it will start from r1 vector to r2 vector like that cube, and within the bracket you can write r1 2 vector like that. So similarly, we can simply write in that way. And just to remember the mnemonics, as I said, if it is the force or the notation here 1 2, then you have to write r1 r2 here, r1 vector minus r2 vector with a modulus and then cube. And here it is what, r1 vector minus r2 vector, here no modulus, but 1 2 1 2 here, here 2 1, so 2 1 with the modulus, 2 1 without the modulus here. So like that, it is very easy to remember also. Now this is all about the Coulomb's force in terms of their position vector.